All right. So let's just begin immediately since we used up most of that time. Um, so we ended up with the first PowerPoint for functions, if I remember. So for today, we're gonna finish up, if we can, the last two remaining PowerPoints for the crash course for Python. So hopefully we can finish it today. Next week, we'll be focused on web scraping, and then on our last session, no, I mean on your last session with me, it will be with uh Python pandas. We'll be learning about pandas. So yeah, hopefully we can keep up with the schedule. If not, then Mom Shai will be the one that will continue where I left off. So yeah. Where okay, there you go. All right, so for this PowerPoint, we're just mainly talking about lists and dictionaries. So they are another type of data structure in Python, and they are very useful data structures, especially for complicated types of data. So a list um, allows a programmer to manipulate a sequence of data values of any type. So you've encountered lists um, most of your lives, right? So a to-do list, shopping list, mostly any kind of list, really. But the difference between that list and here in Python is that we can, it has to have some kind of data type. I mean, you can mix and match the data types, but it makes more sense if it's just one type. So later on, we'll see examples of this one. Forgot my laser pointer. All right. The dictionary is kind of the same as the list, but similar to how dictionaries work in real life, okay, where you kind of skip the first part and then go directly to the information that you want, okay, kind of like a real dictionary. So um so you have a dictionary, right, and you're looking for your word, let's say for example mug. um you skip the letters that doesn't start with M, right? You go directly to the page where the M starts and then look for the word there. So it's kind of similar to how that works. It uses key value pairs, and then using the key, right? So that's the letter that you're looking for. You can directly get the data that you want. So dictionary is very good for mixed data types and those kinds of stuff. So yeah, we'll see more of that later, and examples as well. So here are more examples of what lists are. Um, so I gave this one to you earlier, the roster, a guest list, a recipe, and a bunch of more lists, really, not just the ones here. So each item in the list has a unique index that specifies its position from 0 to length minus 1. Now, if you remember, this is exactly similar to how a string is structured, right? So remember, the string has an index of 0 to 1. And if you really think about it, the list, really, the string is really kind of just a list. They just made it into a uh, dedicated data type just for strings. And we'll see this one in a bit, okay? Useful properties of lists is that since they have indexes, uh, because of the unique function of how indexes work, one of the properties of lists is that it must be ordered, okay? Kind of like strings. So it needs to be in that specific order in order for it to have some kind of meaning, right? If you mix the indexes and jumble the letters around, then it's not going to mean anything, right, for that string. It's also mutable. So when you say mutable, you can change different parts of it. And we've also done that with strings, right? We have changed different parts of the string to another letter and vice versa. Um, Elements. So we call them elements, each item or elements that we have for the list. Um, but in terms of strings, it's just one character. Okay. And the way that we access the list is kind of similar as well to how we access different characters in a string. So using the substring operator, the brackets, if you remember. Okay, so here are some examples. So we already know that this is how we create lists, right? Open and close bracket. Each item inside is separated by a comma, and it doesn't really matter what data type it is, okay? You can even put a list inside of list or dictionaries into dictionaries. You can put layers upon layers of list, um, or any other type, really. But there needs to be a certain point where you should stop nesting more and more because it really doesn't make any sense. So if that point comes, then it means the way that you store data is not really efficient. So you're gonna have to rethink of how you are gonna store the data in a new way that requires less nesting. Okay, the deeper you go, the more the processes it takes, and it kind of just makes everything slower. Okay, the more nesting that you have, because it goes deeper every time when you have a loop, right? So you create a loop, and then you create another loop for another nest, and then another loop for another nest to look for that specific thing. So each loop requires more and more um, memory and processing power. So it's really efficient if you have a lot of nested list or dictionary. So for example, here, when an element's expression is valid is included in the list. So for example, here we have import math and then x equals 2. Ignore the import math for now. Basically, it's just there because we want to use the square root function. It's not really available directly. It's under this library, math.square root. And this is how you access it using the dot method. So math.square root, and then you pass the value of x there, just like a regular function. And what it does is that, just like with functions, it evaluates things first before it assigns it inside the list as an item, kind of like how functions does as well. Um, Whenever Python sees an expression, okay, um, if it's the priority at that time that it must be evaluated first, then it will do that before going outside of the scope. So in this case, it should be evaluated first because it's inside of the list. So it has a higher priority for Python to evaluate that one first. The same as what our principle in mathematics before, the PEMDAS or the MDAS, those kinds of things, if you still remember. So multiplication first, then division, then addition, then subtraction. So the same thing here. Python will always evaluate the expressions inside of the bracket before assigning it as an item. And there we have an example. So the square root of 2 is this value, and then x plus 1 here is just added together, then you have 3. Okay, so this is how it works. List of integers can be built using range. Yes, if you remember the range function, it gives out a series of numbers, right? Because this is a generator function. So if you use a list on it, it will collect all those numbers and create a list out of it. And this is what you get. First, um, this is what the first looks like. And then the second variable looks like this one. So it's exactly the same thing, right? Same value, but they are stored in different variables. So in a way, they're still different. Okay. They just have the same thing. Kind of like uh, having two similar pencils, but you know, one has a different owner, the other one has a different owner. That kind of logic. The list function can build a list from any iterable sequence R of elements. So as long as this word exists, iterable, okay, you can use a list on that, and then it will automatically separate it per item or per element. So see here, we already know that a string is an iterable. That's why if you pass it to the list function, it will automatically separate it by characters. Okay. Now, the keyword again is the word iterable. So whenever you are reading documentations or definitions of other libraries that you find or functions, as long as this word exists, you can directly use the list on it, and then you can see one by one what are the different items inside of it. So this is a really useful trick whenever you are lost in the documentation because you don't know where to go. Okay. Basic operators. Mm, no, so, the len. Okay. I thought it was length. Len is counting how many items there are. So as a rule of thumb, if you use len, it will almost work anywhere. It's kind of a universal thing in Python. And here we are accessing the first item of a list. So first, 0, we're accessing the first item. That's why it comes out as 1. And then here, we are accessing it like it was a range of things that we want to get. So from 2 up until 4, not including 4, right? But 0, 1, 2, 3, and 4, since 4 is outside of the range already of the list here, then automatically the last number will also be included. Or another shortcut of this would be just to remove 4. So it will just be 2 and then colon, and then it will automatically get all the characters starting from 2 up until to the end. Okay, so we've done this one before. The syntax is fairly similar to how we do it with strings. Okay, concatenation and equality also works. Yes, so if you just add two different lists, it will um let's see. It will um just add it to the end of the first one. So here we have 1, 2, 3, and 4. And then you want to add the list of 5 and 6. So automatically it will just be included at the end, okay, of the first variable. Okay. The equal operator, of course, you're just checking if the value is true. Again, you're just checking if the value is true. You're not checking if they are the same object. Okay, you're just checking if their values are true. It's a different thing. If you want to check their um, identity, so to speak, if they are the same object in memory, then you're gonna need a different operator for that one. Okay, and last here for the basic operators, if you want to print the contents of a list, then just passing the list directly to the print function, it will just be printed out as text. So it's perfectly fine to do this. The in operator detects the presence of an element. So if you remember the in operator, we use this one to check if a certain substring is within another string, right? Like for the example, um, the string .txt, and then you're asking it if the .txt is in um, the string notebook.txt. So as you know, it's we there, so it will come true. The same thing goes with list. You have a certain item that you're looking for, and then it will search um, the entire list if it has that same item. If it does, then it will return true. If it doesn't, then it will return false, just like this one. Okay. So everything that we have discussed so far, we have already used in strings. So they're very, very similar. Okay. Replacing an element in a list. So these are the different ways. So elements can be inserted, removed, or placed. And the list item maintains its identity, but the state, length, and the contents can change. This is what it means to be mutable. Okay, its identity remains the same. So what is its identity? It's a list. So after changing the length and its contents, it will still be a list. That's what it means to be mutable. It didn't become a dictionary. It didn't become a regular string. It's still a list. So that's what it means to be immutable. So here's an example. We have a list of 1, 2, 3, and 4. If we change the value of index 3 to 0, then we have this one. Okay, so 1, 2, 3, and 0 instead of 4. So the subscript is used to what? Reference the target of the assignment, which is not the list, but an element's position within it. Okay. So what is it exactly? It's the index number, right? It's the index number. So the first session shows how to replace each number in a list with a square or the brackets, um, just like this one. So it's using a for loop here in order for us to loop over each item in the numbers. Okay, the numbers list. And we put index here because index, the variable index changes every time that the loop starts again. Why? It's because of the range function. Each time the loop starts again, the range function will what? Give out a different value. Okay. So basically, this can start at 0 and then continue infinitely until the program is stopped. All right. And now what we're trying to do here under this function, under this loop, so to speak, is we're trying to assign the same number to the same location, but its value now is uh, raised to the power of 2. So that's why we have 4, 9, 16, and 25 in this uh, in this Jupyter notebook. Okay. The next part here uses the string method split to extract a list of words. So in this case, we're making use of split because we know that each word is separated by a comma, right? And if we assign this one to the variables word, this is what we will see. Okay, so it's a list, and then it's each word separated into different items. Okay, and if we loop over that list and then access it one by one, just like this, then what we will get is the text example will be enlarged. Okay, because this is what happened. So word is, yeah, it's the upper function. It's the word of the upper function that makes the text um, grow. Okay, what else? List methods for inserting and removing elements. All right. So of course, we're going to be using methods as well to insert and remove elements, not just using the brackets. Okay. So the first one is append. Now the append here will just add directly an element to the last um, to the end of the last element. Okay. So if your uh, list looks like this, 2, 3, 4, 5. So if you use append on this one, then it will be added to the last part. Okay. So the names are actually pretty simple. Extend, so adds element of a list to the end of L. So basically it's just like it's exactly the same with using the plus sign. Okay. It's just a small difference. Um, insert here. Insert element at index if index is less than the original L. Otherwise, insert an element at the end of L. Okay. So basically, if you wanted to insert anywhere in any part of uh, your ordered list, yeah. We have pop here. This one will return the element at the end of L. So when it returns something, it returns the value of none. So there's really no point assigning this one to a variable. After using the pop function, then you can just um, leave it be. Okay. And then finally, the pop index. So removes and returns the elements at index. Okay. So almost exactly the same thing. The only difference is that this is the second way to use the pop. You're just going to add an index to it at the end. Okay. So if you have any questions, just ask them directly. Okay. Mm, so if we continue now, the method insert expects an integer index and the new element as arguments. So here are some examples that we see. If we say example is equals to the list of 1 and 2, right? So what happens after that? Everyone looked at their variable, right? And then saw that it's exactly the same list. If you say example insert 10, right? And then you have 1 and 10 here. Um, if you say insert, let's see. So at position 1, you're going to insert the value of 10. So if you count here, 0 and 1, right? 1 should be on top of 2. So that is where the number 10 is inserted and moved everything else to the side. So number 2 is moved to the right, number 1 is moved to the left. That's what we see here. Kind of like um, how someone will force their seat, for example, in a train, and then all you have to do is just move to the side so that he can fit or she can fit. What else? Mm, that's all really that I can think of that for now. Um, we'll get back to it later if I think there are more examples. List methods three. So the method append expects just the new element as an argument and adds the new element to the end of the list. Okay. So what we have here is the same thing, 1 and 2. But if you say append and then open append up, you will see the same thing, right? If you say extend 11, 12, and 13, this is what it would look like, okay? The entire group is added at the end of the first group, okay? And of course, if you want to remove the element, all you have to do is indicate the pop, okay? You can also mention the index of the pop, and then It will also, how to say this, be removed if you do it like that. Searching a list. So the in again operator is very useful when you are searching something in a list. It determines whether an element's presence or absence, but does return uh, position of the element, right? So we're going to use the method index to locate an element's position in a list, and then raise an error when the target element is found. So how do we do this? So we have a list here at the top, and then our target is 45. Let's say we're looking for the value of 45. And then if the target is in uh, a list, right? What would happen is that it will just print regularly um, the list that you have, and then it will show you an updated color with it. Okay. Else, then what would happen is that um, let's see. Well, we can just put -1 here if we want, because hmm, all right. So we're done with that part. Let's go directly to sorting a list. So it will become inevitable where you're gonna need to sort something out in a list. Okay. So a list elements are always ordered by what position? This is because of the index number, right? So you can impose two types, a natural order on them, for example, a alphabetical order, and also when the elements are related and comparing them. So we have these operators, less than, greater than, or equal to, that they can be sorted out afterwards. Okay. So in this case, the method sort mutates the list by arranging its elements in ascending order. Now, take note, this is arranging its elements in ascending order. So now, it actually has somewhere that it has to go. Okay. Any questions so far with the list? All right, I'll take that as a no. Okay, so mutator methods and the value of none. Okay. So when we say mutator methods is basically just the opposite. No, wait, not the opposite. This is the real um, methods that can modify how the output works, and then it will also return the special value of none. So let's say, for example, here we have a list, and then a list dot sort is using sort, right? But since this is a sample of how a list, right, is sorted out, usually is from left to right by default, and then looks for the largest number. And it keeps on doing that until it reaches it finishes all the numbers. Okay. And of course, if you just print directly the alias, it's going to return none because this function actually returns nothing. Okay. Yeah, it's just there to be used for computations. All right. So we're now down to aliasing and side effects. So remember earlier when I said that the two numbers are, how do I say this? The two numbers are similar in value, but different in architecture. So basically inside your RAM, if you have a variable, it's stored in a certain location, right? And we call it aliasing if you try to name another variable to be equal to the first variable. So that's what it's doing here. It's trying to match the variable second to be equal to first, but first is equals to square root, no, square root, list of 10, 20, and 30, right? So to Python, what this means is that it won't look anymore for the first variable. It can go directly to like the RAM and then try to see if it will generate an error. In this case, let's see. So first is equals to 10, 20, and 30, correct? And then we have second is equals to first. So now second is the what? The alias of the word of the variable first. Okay. If we check the values of each, we see it here. And if we check the first value of the first index of first, we get a 99. Okay. So it's going to be assigned to the first index, right? Okay. Now, when you try and open first, it will become 10, 99, and 30. But not just for the top part, it's also for the second part, right? So you see, at this point here, um, the index 1 is equal to 20. But in this point at the bottom, the index 1 is now equal to 99. Okay, so I hope that makes sense for aliasing and side effects. Um, of course, there's only one way to avoid aliasing, and that is for you to copy the value itself and then create a different um, name for it. Okay, that's the best way to avoid aliasing. So by the way, while we're at that note, there are different types or ways of how to copy. Um, so you can actually use slice on that thing. So if you say original, okay, this is 1, 2, 3, 4, 5, right? And then this is your copy. My copy, right? And what you're gonna do is you're gonna call the original list and then pass it here. No, no, wait. You're calling already the first one. So what you need to do here is to put columns. Okay. So if you remember this one, what? This reverses a string, right? But in this case, original. No, sorry, I forgot I was on mute. All right, so what's so bad about aliasing? So this is a question by Sir Seji. Basically, if you have something that's been aliased, right, and there is no documentation that it's actually an aliasing, it kind of adds to the things that you have to take note of, right? Especially because um, you're using those variables. Let's just do a quick example here, right? So temp1 is equals to 456. Temp2 2 is equals to temp1, right? And if I change temp2 of the first index to what? 10, right? And then we'll print out temp1. We are essentially changing the value of temp1 as well, right? So what does this implicate? Let's say that temp1 was for used for section one, or oh no, let's do it in terms of teams. By team one, all right. Usually in in a development team, there are if it's especially big, right? It's handled by teams, and usually each team is working on something new. Like, okay, I think this is a better one. Feature one. Okay, feature one. This is what usually happens. And then temp two is used for feature two. All right. Now it just so happens that they are using um the same thing, right? One of the developers, right, just made an alias for temp one because I don't know for whatever reason why he did not just create a new one. Um, but what happens with that is that different parts of your program are using the same thing. So if one part of the program changes something in that list, okay, it will affect the other part as well. What if that variable was for configurations, right? Or settings, for example, okay, global variables that can affect how your program works. So at this point, when you think about it, it can affect negatively your program, right? Um, so yeah, that's one of the reasons why it's not really used a lot. Anyway, it's highly encouraged that you use unique names, right? Unique names for your variables and try to avoid aliases like this one because it can be kind of um annoying to trace when you're debugging. Like you don't know what happened to your variable, why did it change, at what point did it change, what was the function that changed this value. So it's not really an error, right? So it's not going to help you with anything. The output console won't show any errors because it's not really an error. Okay, so I hope that answers your question. But yeah, you don't see aliases a lot in an actual code. All right, so let's get back to where we are. Um, yeah, to prevent aliasing, you're gonna have to create copies, and there are a lot of ways to create a copy, right? This is one way. Um, so you say print my copy. So you could just copy it, right? It's really easy to copy things. So just like this one, it's 1, 2, 3, 4, 5. And if I were to change um, original here, right? Let's say index 1 to 55, okay? And if I were to print both of them, okay, you can see that The other one is not affected anymore because it's not an alias. Okay, right. So at this point, the object identity and structural equivalence. So this is the point where we can check if something is they just have structural equivalence or um they are referring to the same thing in the memory. Okay, so we're gonna have to explore a different operator here. And it's actually the is operator. Okay, so at this point, if you say print temp1 is temp2, okay, it's gonna say true, okay, because in memory, this is located at in your RAM, it's located at somewhere 0x344244, for example. And since temp2 is referring to temp1, then it will just go directly to the same address, to the same memory address in your RAM, right? So that's why it will say it's true. Okay. This one here, if we say print is my copy is original, it's going to say false because they are both referring to different things. Okay. All right. So yeah, I hope that's clear. So other than this one, somewhat clear. All right. I'll try to think of some other examples while I'm discussing. Other examples where aliasing is not really like, how do I say this? Encourage. It's not really encourage. So I'll think up of a better example. Um, so other than this one, the double columns here to make a copy. The other methods for creating a copy is using the list constructor, right? If this is a list, then you can create a copy of that one as well using the list constructor, copy two. You will use the list constructor here and then just pass in the original. You can make a copy of something like that. What else? There's also the copy method. Um, so how do you use the copy method? You call the original first, and then you use the dot method, and then copy. Yeah, just like that. So this is only for Python 3. So if you're using an older version of Python, or if you happen to be in a situation where you're using an older version of Python and you found out that this doesn't work, um, yeah, just remember that it only works for Python 3 and above. Okay. What else? You can also use the copy module. So there's actually a copy module, but you'll have to import it first. Copy, and then you'll have the original here, right? And then what you're gonna do is you're gonna say my copy. Okay. You're gonna say was it copy the deep copy? Yeah, deep copy. And then you have one, two, three. Oh no, wait, pass in the original here. There you go. So all in all, you have four different methods of making a copy. So this one, this one, this one, and this one as well. Oh, I thought this was an error. It was just for grammar. Um, of course, you can do the old way where you're gonna use a for loop and then you're gonna access each item one by one and then assign it to a new blank list. So that's an older method, but it's kind of um, unnecessary anymore. We have a lot of ways now to make a copy, especially this one, right? Okay, so let's go back to our PowerPoint. Mm, yeah, I think I discussed everything. Okay. All right. So median is a statistics term, right? If you remember. Um, Basically, this is the midpoint, right? Of where if you have a set of numbers and then it's arranged in a specific order, right? Usually ascending. So if you are looking for the median, you're looking for the midpoint of those set of numbers. So basically, this is just a program to get the median. Let's see. Mm, okay, all right. Let's just do this one. But we'll not stick too deep into this because again, um, we're not really focused on creating uh, functions ourselves. We're more focused on understanding functions because most of the things that we need, there's already a function for it created by someone else or a different library. Okay. Um, it doesn't mean that we don't have to create functions ourselves, but it just means that um, simple things like this one, the median, the mean, the mode, there's usually a function for this already. And it's unnecessary for us to actually create one ourselves. So this is just for us to explore further um, using our current knowledge to create something like looking for the median. Okay, so let's go over this. Not too fast, not too slow either. So let's say you have file name, right? So it's using a file name and then you're asking for the input, enter the file name. And then we're going to use the F for the variable. Let's open the file and then we'll pass the file name here. We will open it using the R method. And then what can we do here? Numbers, right? It's using numbers. Yes, numbers. Okay, so numbers. And then for line in F, we're going to access it one by one. And then for each line, we're going to get the word. So we're going to say word is equals to line dot split. And then for word and words, we're going to loop over it again because we're going to get the numbers there and we're going to append it. Um, we'll just assume that the numbers have decimal points. So we're going to use float in this. Float, right? I think it's using the same thing, float. Yep. So after looping over it, what do? We sort them out. Number dot sort, numbers dot sort. And then all we have to do now is look for the midpoint. So the midpoint is usually where. So if you count how many items there are, right? And then you divide it by 2, um, that is usually the midpoint. So I'm using the floor operator here because I want to truncate the decimal part. I wanted to get the whole number only. Okay. So we're gonna say print maybe the median is, and then we need to check if the numbers are odd or even, right? So we're gonna use the modulo operator. So if len of numbers, am I using open and close parentheses? Len of numbers modulo 2 is equal to 1. That means if it's an odd number, um, that means automatically we can just directly print the midpoint itself. So numbers of midpoint, that is automatically the midpoint because it's an odd number. But if it's even, right? The way to get the midpoint if it's even is you get the two numbers midpoint, and then the one before that, numbers midpoint minus 1, and then this is the one that you divide by 2, and that is your new midpoint. Um, yeah, I think that's it. So in our home page here, home directory, let's create a new file. I'll name this one for median, right? And since it's looking for what? Line, and then it's gonna split, right? Basically, we can um, edit. Where's edit? New open. No. File. Where's the edit here? Open editor. Ah, okay, there we go. Okay. So meaning we can just put any numbers with spaces in between them. So I'm just gonna do this real quick. Mm, Not too varied, right? Yeah, I think this will do. So I'm gonna save text. And then we'll say run this one, median.txt. And I think there's an error somewhere. Words is not defined. Words, this is on line 7 for word and for words. Is it for words in word? Oh, no, this one should be word. This is words. Okay. Again, median.txt. And there we go. The median is 55. So that is the median for all the numbers here. Okay. So if we check how many are there? 2, 4, 6, 8, 10, 12, 14, 15. Yep, so it's gonna arrange that one first and then get the middle point and the one before that to get the median. Okay. So not exactly the middle point because again, it's an odd number. Okay. So I hope that makes sense. So it's a really simple program, nothing really fancy, right? Nothing new, like out of the ordinary. We already know how to use for loops. We know how to use append on the list. We already also know how to use the split, right? So if you remember the split will, what it will give out a list. So that's why we can loop over it again because it is an iterable. So loop over each one and then append it here, convert each word into an actual number, right? This is what we're actually doing here. Get each number, convert them to a actual number data type, and then process it afterwards. So after that, we can then manipulate it however we want. And that's what we're doing here and trying to get the um, median. Okay. So what we're doing here is almost exactly like what we're going to do with data science. You have a certain raw data. You're going to have to process it. You're going to remove all the unnecessary values like the zeros, the nulls, the no entry, and then what you are left with are actual useful data. And then after you get that data, after you get it processed, it's now become useful. So now you can start manipulating it. You can plug it to a machine learning um, library and make it predict some stuff. And then afterwards, at the end, we're gonna create some graphs out of it and then publish it or show it to your uh, supervisors or bosses and the like. So, any questions here? Um, with this program. So it's relatively simple. If you just follow this one, I think it's pretty similar. Um, yeah. Mhm. I think in chat. Okay, so I'm gonna proceed. Okay, so now we go to tuples, right? Now all you need to remember with tuples is that it's basically just a list, but the difference is that it is immutable. Now, um, the term immutable here uh, means that you can't edit it in any way. So, for example, here, it's annoying. What's happening with my anaconda? Okay, so we have temp, for example, and then I have numbers here, so 5 and 6, right? This is a tuple. If I were to say temp of 1, then I'm gonna change it to number, it's gonna give me an error. Okay. Tuple object does not support item assignment. Now, when you think about it, you might be thinking that this is an security thing, like it makes things secure, but not really. It's more like avoiding accidental um changes, right? Like you accident like if there are two variables that have um their names are differ only by one letter, for example, and then you accidentally edited the other one. So if you set it to tuple, it means that you can prevent that kind of accidental um occurrence, and then it will be a lot easier to trace because nothing was edited from the other variable. Um, you can also use this one if you want to make something permanent, like the settings, for example, and it can only be edited if the user actually has intention to edit, right? It doesn't mean that you can't edit it anymore. There are a lot of ways that you can still edit a tuple. It's not really for security. Again, it's for um, accidents, right? So that it won't happen. Um, So basically everything that we can do with list, we can also do with tuples. So what you can see here is that we're adding two different tuples, the same with list, still the same. Um, Same behavior. We can, what are we doing here? We have meats plus fruits. This is now equal to food, but veggies here is a list, right? So if we have a list function, if we have a list function, then we also have a tuple function, right? So this essentially just converts it to the other. So if we say um, temp2 is equals to list of temp, and then I'm going to print out temp2. Okay. Now you see that it's become a list, right? So this is one way of converting a tuple to a list. Or you can do this one and vice versa. Let's say, for example, you have a temp here that's already a list, and then you want to convert this one into a tuple. Tuple is not defined. There you go. So now we converted the list back to a tuple. So technically, what you can do is convert the tuple first into a list, edit the things you want, and then convert it back to a tuple, right? So just with that concept, it's very easy to edit a tuple, but the difference is that you are intentionally doing it, right? You are making conscious effort to edit a tuple. So that's the difference. Again, it's not for security purposes, so don't use it for uh, that kind of purpose. All right. So defining simple functions. There. So defining our own functions allow us to organize our code and existing scripts more effectively. And basically, it's just a brief overview of how we create functions ourselves. Okay, let's see. Right, so this is the syntax of how to create a function. So you start with the keyword. There we go. So you start with the keyword def, followed by the name of the function. And then inside of the function or the different parameters that you want, so param1, param2, param3, right? And so on and so forth. After that, a colon afterwards. And then just regular indentation. And then this is your what? Block of code, right? So that's it really in defining a function. Um, just for context, when you want to call a function, what do? You call the name of the function, right? And then what do you do afterwards? You pass in the arguments that you need. So argument 1, argument 2, argument 3. Okay. So argument 1 will go to parent 1, arg 2 to parent 2, arg 3 to parent 3, right? So we've used this one a lot, but this one not yet, right? Maybe a few times. Forgot. Did we actually define functions here? Let's see. There. Nope, this is the first time. All right, so basically it's just the difference between parameters and arguments. So we've already discussed a lot, right? In the very beginning, I remember discussing the print function to you guys on how to read a function, right? It's one of the most important skills that you need in understanding what parameters are, what arguments are, and what they do to your program. Okay, so just a quick recap. Um, Parameter, right, is the name given to the temporary variables inside of your functions. They temporarily store the data that is being passed to them. Okay, the arguments. Okay, when you say arguments, they are the what? They are the actual values themselves, right? Um, there are default values for parameters. If you want, you can indicate it by using an equal sign and then the value afterwards for default values. Um, the placement of the arguments corresponds to the different parameters. Okay, so if your parameters have no names, I mean, just like that one, param1, param2, param3, right? If you arrange them in the same order, they will be assigned to that order as well. Okay, but if you were to call them specifically, like param2 here, and then assign a value, pass the argument manually, okay, it doesn't matter what position this argument is placed, it will always go to param2 because you are specifically referring to the parameter name. Okay. What else? Always remember the indentation in defining functions. So basically just like what we're doing with for loops, the ifs, the else, okay? So whatever you were doing with indentations before, just do that as well for defining functions. All right. What else? Mm, Parameters are the ones responsible for changing the output or how the output is being processed, right? Mm, so if you have a parameter that, for example, makes the strings capital, okay, or makes it all small caps, depending on what argument you pass. Like, for example, if you pass the argument 1, it will make all the strings capital. If you pass the argument 2, it will make all the strings lowercase. So you can set something like that up. Um, so yeah, again, the parameters just changes the nature of how your output looks. Uh, Also the data as well, right? Of course, you need to pass the data as well, the actual data, uh, to the parameters. Okay, the return statement. We discussed that one. I think we did because we were discussing the values of none with the other methods. Am I correct? Can you verify for me? Return. If I made a comment, and we should have discussed it. Yep, the return. Yep. So I remember this analogy, return and the customer. So yeah, we did discuss this one. Usually it's found somewhere in the code of the function, right? Again, the return statement is what will be, of course, returned to the caller. So this is the caller, then whatever the return statement here, return this, right? If I call name and this is the return value, then it will replace this entire thing with this one. Okay, that's the only thing that you need to remember. You are calling the function, it will go here, it will return this. So it will essentially replace this one with this value. Okay, that's all you need to remember. And then Python will continue processing it regularly, as usual. Boolean functions. All right. Now, from the name itself, Boolean functions, just like with Boolean operators, you can immediately think that there's only going to be two outputs for this kinds of functions. It's going to be either true or false, right? So basically, um, like what it says here, test is argument for the presence or absence of some property. This is the simplest definition that um, we can say about it. So for example, here we have the odd function here, and this is the code that it has. So it returns true if x is odd, false if otherwise. So basically what makes a function Boolean is because the return values are just gonna be either true or false. Okay. There's nothing different with how we create functions. There's nothing different with how we define the parameters, right? The only difference is that the return values will either be true or false. That's it. Okay. That's the only thing that makes it into a Boolean function. Okay. No need to overcomplicate things. So yeah. So there are a lot of functions out there that returns true or false, right? Like the search function, the match function, right? It tells you sometimes that there's a match or there's none. If it's not true or false, it can be also one and zero. It can be considered as a Boolean function if it's one or zero. You might notice other functions like that. It returns one if it found something, right? Or it's a match to something, and then zero if not. So yeah, take that into account as well. Defining a main function. We don't actually deal with this one. The main function is for when you are trying to export this file, this program to be used by somewhere else. So remember this part where we say import, where is it? I wonder if we can see it here. Print main. Okay. Maybe it's double underscore. Nope. Let's try two underscores. Let's see if it can see it. Hmm. Okay, well, it has a different name here. Oh, forgot the other underscore. Okay, so that's a different name. But basically, what the main function here stands for is that this entire thing, this entire notebook, right? This entire thing is inside of a main function. Okay, so just imagine, right? We have a def main function, okay, that has no parameters and has no return value. So you put all of the code that we have written so far from the very beginning up to here, you put all of those things. Yeah. So we put all of our code, okay, from the very beginning, 90, from the very beginning up to the end, right? All of our code is inside the main function. Now, when we open the file, right? When we open the file, this one, um, what Jupyter Notebook will do, or what Python will do, is it will run the main function so that we can see, right, everything here. We can make the Jupyter Notebook work itself, okay? the entire Jupyter notebook is somewhere inside the main function. So that's why we can use it like this one. All right. Um, so that's basically it. If you want to, like we're actually opening a file, and then all of it is inside of the main function. Now, if you were to open this file as an import, right? Kind of like how we do it before with an import function, okay? Like for example, import math, for example. So math here is just a file also, just like the one that we have here. But inside math, there are two parts. One is um, code outside of main, and then there's also code inside of main. Okay, the code inside of main will only work if the math file is being opened itself. We are opening the main file itself. If we are importing math like this one, like we're just using the file, we're basically just getting the things that we need. So if you're importing the file like this one, you're not going to see the code inside of main. What you will see are all the code outside of main. You get the idea? So this is how this file is structured. Basically, you can divide it into two parts. You can also just remove this one entirely if you want. So you're just stuck with this one, okay? So it can only be used if it's imported. So if you run it as it is, then it won't actually do anything, right? So again, this is really useful for us right now. It's more of when you want to use your script as parts of other scripts, okay? But we're not going to be doing that one in data science. It's not really necessary at all. What we are going to be doing is we're going to be importing some stuff. So that's what we're going to be doing. We're not going to be exporting stuff. So we can just skip this one entirely. But at least you know, right, how it should work. Mm. Oh, it also has an example here. That's nice. So you can try this out if you want. Basically, if name. All right, so it's actually called name. So if you say print name. Okay, now it says the name is main. That means we are running the file, right? Itself. We are inside of the main function. So this is proof of that. It says main. Um, because it needs to check that one at the beginning. If name is equals to main, then it will run main itself. Okay, so there we go. So this is actually used also in other languages. So it kind of has similar structure, really. If you are familiar with this one here, then odds are if you study other languages, then you'll also become familiar with this one, the main function. Uh, yeah, so that's it. Dictionaries. Let's go to dictionaries now. Mm, yeah. Dictionary. So a dictionary organizes information by association. All right. And like I discussed earlier, it's good for organizing data of different data types. Um, Properties. So if you were to define properties for dictionaries, they would be unordered. Okay. It doesn't need to be unordered. Um, it's mutable still. You can edit things. And instead of index numbers, it's using keys and values. Okay, so key value pairs. I call them key value pairs. Um, and then accessing it is essentially the same way as how we do it with list, but we're gonna be calling them with their keys instead of their index numbers. Okay, of course you can use numbers if you want as the keys, but it makes a whole lot of sense if you're using uh, actual words to describe the data that you have inside there. So just like with list, you can um, put other stuff inside of it as well. You can put dictionaries inside of dictionaries, lists inside of lists, and so on and so forth, of any kind of data type. Okay, all right, let's go. A Python dictionary is written as a sequence of key value pairs. Yes. Sometimes they're called entries. It's denoted by the open and close curly brace and then separates the key value pair by a colon. So basically, this is what it looks like when you want to declare a dictionary. So as you can see, open and close curly brace, you have the key here. The keys are usually in strings. Um, it's very, very rare that you see a key that's not a string. It's usually a string. Okay. And colon, and then after that is the value associated with that key. So key value pair. That's what they call it. And then just like with the list, you separate things with a comma, right? And then you go to the next item. Okay. Here's another example. Here's an empty dictionary. So reading it like this is kind of difficult, right? The way that we usually do that here when, yeah. So let's say temp, right? And then I have a dictionary. Let's say we'll create a user profile. So name, my name is Daniel, comma, enter. Age, my age will be what? I'll make it 50. You can press enter here some more. Okay, comma. Right. So at this point, I'm just aligning things. You can say, what else? Age. Let's make a list. Favorite books. Let's say this is a list of strings. Okay, so favorite books would be, I have a lot of books. Let's just stick to movies, maybe movies. Okay, let's maybe to movies. Fave movies. Let's go with some old school. Army of Darkness. Army of Darkness. Or maybe um, mm, Waterworld. I don't know if you guys have seen these movies. Waterworld. The Raid. Yeah, that's cool. The Raid. Yeah, let's just stick with three for now. Um, so as you can see, I've created a list here that is a value. Okay, and this is the key associated with that one. All right. Let's also have another dictionary, like another dictionary. Let's say, mm, okay, let's go to books now. Fave books, but we'll do it with genres. So this will be another dictionary. Okay. Um, so at this part, we'll have the key as genre. So maybe horror, and then the value is, what are horror books? Uh, I don't know. Archie. It's not really horror. I'm just out of ideas. What else? Comedy. Maybe we have mm, comedy. The Divine Comedy. Divine Comedy. All right, so I'll just take the two, and then I'm gonna close it now. Okay. After that, one more thing in the end. Let's add, what else? Name, age, movies, books, address. Yeah, we can put address. Okay, we can put here Philippines. And that's it. I can close it now. These things, the red things are just from Grammarly, so you can just ignore them. Can I turn it off with this site? No. Mm, never mind. Right. So I have a dictionary now. If I just use the print statement here, a print function, and then pass directly the dictionary, it will print out exactly the same thing. But the great thing about this is that if I were to access, let's say, string, right, name, for example, so that if I were to access it, I will say temp and then substring operator, and then instead of the index, you will use the key. So the key here is name. Right? So if I were to run this, it will just print out the value associated to that key. Okay, so you see the uh, effect here. If you also use fave movies, right? Now it's accessing a list. Okay, so this is essentially a list now. Okay, so if it's a list, then automatically what? We can use list methods. So we can say sort, none. Okay, it's not really sorted out. Um, why didn't it work? Hmm. Maybe it didn't sort because we have spaces. Let's just use something simpler. String methods. So list, right? So if I want to use a string, then I need to access item one. So that is index 0. Now it's a string. So if I were to use a string method like upper, now I can do it like this. Okay. So remember always at that point what data type you're using, what no not data, yeah, what data type you are using at that point of your chain. So at this point I'm still a dictionary, right? But after accessing fade movies, it's a list. So at that point you could have used list methods. um Here it's we're accessing the first item and then using a string method, right? You can also access further um, another dictionary, so fave books, right? And then I want to access another item there, the comedy one. And then we can also use the what? The split method to that to get a, sorry, comedy. So as you can see, you also need to specify that it's a string when you're accessing the keys. It must also be a string as well. Okay, so there we have it. This is the flexibility of dictionaries, right? And again, it depends with what kind of data you're actually trying to store. Okay, there are advantages of using lists. There are also advantages of using dictionaries. So dictionaries are great for things like this one, user profiles. So you can store different types of data that pertains to a single entity, right? The context is pertaining to one single individual, whereas a list is good for generalizing things like there were 100 people, these are their ages. You can put it all into a list and then maybe get the median out of that one. Okay. So those two data types just uh keeps on being converted from one to another. Like there's data in dictionary that you can put directly on list and vice versa. So that's for dictionary. All right. Okay. So again, here they are normally strings or integers. You can also use any keys, but as long as they are immutable types, right? So what does it mean? It means you can use what? What is something immutable that we have used? We have used tuples, right? Tuples. So if you were to access something like this, okay, and then you were to access the tuple, let's see how can we access this one? Temp and then 5 and 6. Let's see if this works. Yep, it works. So as long as the key is immutable, right? It has the immutable property, or in the description it says it's immutable, then you can use it as a key. Again, it doesn't really make sense, right? Like in what way would this one be useful? Um, I don't know, but I've never seen dictionaries with tuples. We're just doing this just to show you that it works. Okay. Adding and replacing values. So it's basically the same as what we do with list. You access it using the subscript operator, and then you assign a new value to it. And then you can change the value directly. Okay. So we have info here. We're adding something, Sandy, occupation, hacker. Okay. And it will automatically look like this one. If you were to change it, just assign a new value to it, access it, and then assign a new value. And as you can see here, we change it from hacker to manager. Um, Here, it's just showing that it's gonna return an error if something doesn't exist. Okay, if it's not present. So, why is this added here? It's because you need to address this kind of issue. You need to um, take this to account, especially in data science where you're dealing with a large amount of data. If a single error occurs, then your entire program stops. So if just imagine if your program was running around 2 hours and then it stops because of one error. So again, that's just wasted time. Make sure that you take into account things that doesn't exist and what to do when that happens. So any kind of error. I mean, you have to always remember that one. Um, so one thing that we can do is we can check if the key is existing. Okay, so using this one, if job in info, you can use the in operator here to check if a certain key is inside the dictionary. If it is, then it will do something. If not, then it will just inform the user of an error, but it will just skip that one entirely. How does it skip it? Maybe it will automatically use a default value. Like for example, if the name is not present, then it will put a blank there or a space for that key. So yeah, removing keys is just as easy as what we do with list. Even the name is the same, pop. So yeah, you indicate it with the name of the key and then the optional default. Okay. So um if job does not exist, then the result is none. Yeah, that's it. So the none here is the default value if the entry does not exist. Again, if it exists, then it will automatically just delete it for you. Okay. So as you can see, info here is just one entry only, and that's name for the keyword pair of name. Traversing a dictionary. All right. So there are a few very useful functions that we can do. Okay. First is if you want to print all the keys, then you can just use a regular for loop. So we know that a for loop or the in operator can access different keys, right? So if you put this one into a for loop for key in info, where info is the dictionary, okay, um, if you just put it in a for loop, then you can basically see all the keys inside. And if you put info subscript of the key, then you'll also see the values associated to that key. Here's the alternative. It uses the items, but um, each entry is saved as a tuple, as you can see here. So 80B, 90A, 70C, where 80, 90, and 70 are the keys. BCA are the values. Okay, it's saved in tuples if you use items. We also have this one. Um, if you know that you're dealing with a dictionary, okay, and then you can use it directly in a for loop, okay. Since you know that items will return, um, not really return, more like give out each entry as a tuple, you can put it in a for loop and then receive it in a tuple format already, like this one, key, value, and then you can access them individually directly. Okay, if you want to do something with each entry, you can do it like this. Okay, so there are other methods for dictionaries. I leave that one to you guys to research the other methods for yourself. Again, what better way to learn than to actually experiment with it, right? So again, if you want to search for those things, it's just as easy as using the terms like Python and then dictionary and then methods. And then there will be a lot of resources for that one, especially here in Python itself. So we have the official documentation here. This is just for a list. Where's dictionary? Okay, I just clicked the one for a list, but there should be one also for a dictionary, right? Let's see what's next. Info and keys. Yep. There's also the keys function. Can someone use to experiment with those dictionaries? Hmm. What possible scenarios? There's actually a lot. So one of those is the uh this one, the user profile, right? So where do we usually see this one? So let me give you some scenarios. So user profile, okay. Yeah, one. What else? We can use this one for different types of records or for all types of records, really. Okay, so if you want a specific record like bank statements, maybe online transactions. So if you think about these things, it pertains to different data, right? So bank statements, what do you have? You have account numbers, you have dates, you have strings, names of people, um, previous transactions that they have, right? Or if you have an online transaction, for example, a single transaction has a lot of data in it, like who is the buyer, who is the seller, where is it going to, where is it coming from, who is the um, or like what are the different couriers that you are using to deliver the item? Is the item fragile? Is the item um, did the user add some kind of extra? Did the user click that extra something to add more protection, like more bubble wraps? What else? So there's a lot of data that pertains to a single transaction, okay? And all of them are of different data types. So a dictionary would be really good for that kind of data. And then you store everything, okay, and then save it as a um, the variable name will not be like how we do it here. It will be something like random numbers and then random letters. This is usually how it's stored in the database. Okay, so this is for transaction A, B, D, B, number, something, something. And then this is what it's stored in the database. And this is what you usually see in the database. So why is it like this? It's because um, it has a lot of possible values. And then once the transaction is complete, you can store it away and use some other values for it. So yeah, I hope you got the idea. So any kind of data that pertains to different data types, and then you have to store that as one variable. It pertains to one single thing, one context. That is where dictionaries are good at. Um, so while we're at it, let's go to list, right? So if we change your question to what possible scenarios can someone use to experiment with list? So there's a lot of it, right? Let's go to Facebook. Let's go to comments, right? Let's say these are the different comment tags that you have uh, used for this transaction, for example. So you can put the entire transaction or the entire post in a dictionary, and then in one of those key value pairs, there's a list there that connects you to the other post with that specific number. Like you have the comments of the following numbers. Okay. Comment here, comment here, comment here. So these are the different um, data, right, that has a comment to your post, right? So essentially, these are the people that have commented on your post. So, um, so what does this mean, right? And then each other person will have their own comments, right? So what does this mean in terms of data science? It means you can track all the comments that is related to that post. And then you can kind of like draw a tree of that um, entire post and where it's connected to. So imagine a post that has millions of reactions, millions of comments, and you can actually trace that one by one. Okay, and they can actually do that. It's stored in their database. So yeah, I hope I'm making sense here with my examples. Yeah, any other questions? All right. So I'm guessing there's none. Okay, I'm gonna proceed. Basically here is just a summary of what we have learned so far. So len again can be used the same thing. If you use a len on a dictionary, it just counts how many key value pairs you have. This is just accessing it. The get function. So you can use the get function as well to avoid errors, like like what we did with the if you use the in operator, but there's actually the get function returns the value if the key exists or returns the default value if the key does not exist. So essentially it avoids giving out an error for your program. List also has its own no, wait, not list. This is the list function, but the dictionary has these kind of values, methods, keys, values, and items. So items from earlier, it will just give us the tuples for key value pairs, right? Keys will obviously just give us the keys. The values will always just give us the values. So you might be thinking, what possible reason could we have used for just detecting the keys or the values? There's a lot of use cases for this. Let's say you have a dictionary, right? And then all you need is to get the maximum value for that specific data set. So what reason would you have to go through to all accessing each key, right? Where you can just get the entire value and then look for the maximum number and then do the opposite. So instead of searching for the key, what you'll be doing is you'll be searching for the value. So that's one of the cases that I can think of. Clear, uh, just just clears everything out. And just this is just a standard for loop that you see here. So here's something that we can revisit, like a lookup table. So in this case, for each digit in the hexadecimal system, right, has the equivalent binary as its value. So basically, you can use this one to make it a bit faster to convert one thing from another. But again, there are more, there's a lot easier way than doing things like this. Okay. Again, I'm not saying that we're not going to be creating functions. I'm just saying that most of the time you're going to be using the functions from other libraries. The only time that you'll be using the function, creating a function yourself is when it doesn't exist or when you want to create a certain process that you want it to be automated by using a function. That's basically it. Or you want to create loops. Um, Building an entire function out from scratch, like this function will um, do the, I forgot the name of that kind of algorithm that follows a certain algorithm to get the most efficient steps in assembling a Rubik's Cube, for example. So, um, yeah. So this program here is just to use that table earlier that we saw to convert it directly to binary, as what you can see here. So it creates a function and then we pass a number in a table, but you know, it's just basically replacing each number here, X number to its equivalent um binary value. So A, it's 1010. If you go back to the table here, A is 1010. Um, you have 5 and 3, which is what? 3 is 0011 and 5 is 0101. So it's 0011, 0101, 1010. So it's correct. Um, so that's basically the use of that table. There's nothing fancy on this function. We're just accessing each digit from the number and then get the equivalent from the dictionary, get the value associated to that key, and then print out the value afterwards. So that's it. The mode. This is just basically the same with what we did with median. Um, the only difference with mode is that uh, mode, the value that, oh, it's here, the value that occurs most frequently. There we go. Yeah, don't worry, sir. Well, while you're at it, it's only 3:10. Let's just take a quick break. 15 minutes. I want you guys here to be back by 3:25. Okay? So 15 minutes and then we'll continue this one and the next PowerPoint. Okay? So see you in 15, guys. Don't leave the room. Just um stay. I'll just block the video and audio. Okay? Okay, I hope you guys are here. All right. Thumbs up, just to confirm. Low, low. All right. So, Sir RJ is here. I'll assume the others are here as well. So I'll just proceed. Okay. So, oh, look at that. We're at the end already. Let's see. Yeah, I think I can leave this one to you guys. It's a fairly simple program. Nothing really new that um we haven't encountered. The only part here that's new is that it's using dictionary um to get all the words. So remember that mode here is the value that occurs most frequently, right? Um, excuse me. So if you have a sentence, for example, or a paragraph, and you want to get the word because that's the value that occurs most frequently, then how are you going to do it? So you're not going to be using a list. The easiest way is to use a dictionary. So let's just break down the program block by block. So at this point here, it's just basically us getting each word from the file and then saving each word as an item on a list. Okay, so all the words in the sentence um, are placed individually as an item on a list. At this point here, there's also an explanation here. Obtain the set of unique words and their frequencies, saving these associations in dictionaries. Or in other words, starting at this line up until here, okay, what it means is that uh, it scans the list, okay? It takes a look at the list. If the word doesn't exist, then it creates a new entry in the dictionary. So let's say it sees the word the for the first time. So it will create a new entry in the dictionary. It will say the key is the, and then the value is one. This is what we see here, right? But the second time that it sees it, the word the, um, it can detect that one now. So it will not go back here. Instead, it will go directly to the else here where the word was already seen before. So what does it do? It just gets that value, okay, and then adds one to that value. So now instead of one, it will say two because it has seen it twice already. Okay, you understand? And it's going to repeat that logic for all the remaining words. Okay, just as simple as that. Okay, get each word, each unique word. Okay, and then just count how many times it has repeated. Okay, and the number of repetitions for that word is the value for that word. Okay, so basically, what it would look like is something like this. You have a dictionary, right? Let's just call it temp, and then you have the words, right? Like the, okay, this is repeated one time. The and, okay, this is repeated five times. The the word key was repeated six times, and so on and so forth. So this is the final dictionary that you will get. Okay. And what it does after that is it will find the mode. Okay. So how does it find the mode? So it uses the max function, and then take a look at this point. it takes a look at all the values, okay, and then gets the maximum value, like what I said earlier. So it will get all the maximum, it will get the maximum value of all the values, and that will automatically be the mode, okay? Uh, so that's it really. All that's left is to scan each key and then look for the key with that maximum value. And then automatically you know that that key is the word that's repeated the most. The only thing that's missing for this code is that it doesn't take into account words that have repeated, that have the same values. So for example, the word and he was repeated 6 times, both of them. So it means that the mode should have been both and he. Okay, so there are two modes. So it doesn't take that into account because what it's doing is it's looking for the maximum and then printing it out and then uh using the break keyword to exit out of the loop. Um, so that's the only thing that's missing here. If you want to print out the all the modes, then what you can do is you can create a extra blank list here and then put all the modes there that has the same value as the maximum value and then print that one out. And that's the easiest solution that you can do. So again, it's not really that complicated. Um, it's fairly straightforward actually. If you just um sit down and then look at each line and then understand its purpose and what your ultimate goal is. So it's a kind of back and forth view. Okay, you take a look at each line, what it means, what it does, and then you also have to take a step back and look at the whole thing, just so that you won't get lost on where you are currently in your program. So yeah, don't lose sight of your goal. And that's it, basically. That's a summary for now. Actually, we don't have exercises for this PowerPoint, mainly because it's just dictionaries and lists. Let's see. Or maybe we can have one. Let's see. Let's see if I have some here from my previous classes. Give me a moment. Okay, so let's just stick to something simple. I actually have two here that we can do. Um, Nothing too difficult. I'm sure you guys can do this. So here's the first one. Okay. And here's the second one. So it's a two-part exercise. Oh, no, wait. I mean, there's two exercises, mainly because it's not really that difficult. So, hmm, all right. So, um, I want you guys to just pick one, okay, in order to save time. Um, so just I'll give you guys up until four. I guess that should be enough. I think that's more than enough. So yeah, up until four, but 5 minutes before four, I guess we'll check your solutions. So in that way, we'll have 1 more hour for the next PowerPoint. Um, so yeah, just pick one exercise that you want to solve. One is for list, the other one is for list and dictionary. For number one, write a function that takes a list of numbers as input and returns a new list with only the even numbers from the original list. So it involves list and creating a function. This one, it involves list, dictionaries, and creating a function. So write a function that takes a dictionary and a list of keys and input and returns a dictionary with the values from the original corresponding to the keys on a given list. So for example, um, for exercise number two, let's say I have temp here. This is my dictionary. So let's say I have A here, and then this is equal to 1, B is 2, C, this is 3, D, this is 4, and then E, this is 5. Okay, so this is my dictionary. And let's say my input list, my input here, input list, it doesn't accept the word input. If my input here is, I want to get the values of A, C, no, not the values, the data for the following. So A, C, and then E, right? The output that I should see here is, um, it should be A, 1, C, 3, and then E of 5. All right. So is that clear? This is your dictionary. Okay. This will also be a input. So that takes a dictionary and a list. So you have two inputs, the temp and the input list. And then it will return a new dictionary with the values from the original dictionary corresponding to the list. So it says with the values, so you have to indicate the key as well. So that's why the output here is still in dictionary format. Um, and you can see the key value here is here associated with what the user was asking for. So this is an example output. Okay, so these are the two inputs. This is your output. Okay, for exercise number 3. So yeah, the time starts now. All right. If anyone has an answer, let me know and we can check it. All right. So it seems that no one is done yet. Okay. Last 5 minutes. Then we'll answer it. All right. So Sir RJ has an answer for number one. Okay. Let's see. Share all participants. Okay. You can share your screen now, sir. The floor is yours.
Hello sir, rinig po.
Yes, but I can't
Ayun.
see your screen.
Ay,
You are screen sharing. Stop share. Okay, there it is. Okay, I can see
okay
your
na
screen
po.
now. Yes.
So, gumawa lang po ako according po dun sa instruction. Asan na instruction? Ay, nawala. So, mag-i-input po yung user ng list ng numbers.
Mm.
So, naglagay po ako ng input. So, nilagay ko po dun sa instruction, mas-separate po sila ng spaces para pag in-split ko po, para mas madali po siyang ma-split ng into single number. So,
Mm.
gumawa po ako ng unang list, which is yung numbers. Then, dun po may input lahat ng mga in-input po ng user na numbers. Then, for the even numbers po, kaya ginawa ko pong int to, kasi po, sabi nyo nga po dati, magiging string po yon input pagka hindi mo ginawang int. So, yun po yung naging error ko nung una. Nakalimutan ko po kaya. Ay, excuse me. Kaya medyo po natagalan. So, yun po, ginawa ko po siyang int and umokey naman po siya. So, next po is pagkuha po ng even numbers for num in numbers, yung inside po nito, yung mga num inside po ng numbers. If yung num po is 0 pag minodulo sa 2, so ibig sabihin po even po siya, malalagay po siya dun sa bagong list which is yung even numbers.
Mm.
So, trinay ko pong i-run, ito po. Nagbigay po ako ng medyo marami rin pong numbers, 13, 15, 12, 11, 10 to up to 16. So, ginawa ko po, printin ko po muna yung original para for reference. Tapos, print out ko rin po yung mga even numbers. So, okay naman po. Lumabas naman po sila.
12, 10, 6, 2, 4, 16. Okay, so it looks good. Um, yeah, can you try it one more time? Just run it.
Ah, okay, sir.
Yeah.
Ay, ayun.
So there are three numbers. Yes, that's correct. All right, sir. Good job.
Thank you, sir.
So, what about the others? Do you have a different solution, or is it somewhat similar to what RJ did? Sir Imran, Sir Seji, if you guys can hear me.
Trying to
Trying
figure
to, okay.
something out. Even tried searching some things up, but I don't think my solution's working at all. Done. Let me
Uh,
see if I can screen share this if possible. Yeah, I was able to get another website for coding at the very least. So, okay. Because I tried to research more on the problem through Google, and they had this little thing here that supposedly checks if it's divisible by two, and then it
mm,
used append the append function. I've actually gone through a few other tries. I assumed at first that I couldn't use list as a name, and
mm.
because before I went back to this, I tried to use the pop feature, which I thought was pretty simple at first. But even if I use the pop feature, nothing comes up. So I thought this changing this would help, but it doesn't. I thought changing these would help, but it also doesn't. I'm really kind of confused.
So that's okay. Did you understood, by the way, the solution made by RJ?
A little bit, sir.
A
Try to
little
keep
bit.
some.
All right. So I guess I'll show my solution as well, just for reference for everyone. Um, all right. Thank you for that, Sir Seji. How about
Welcome,
you,
sir.
Sir Imran?
Sir, no answer pa po eh.
Either exercise one or two?
Yes sir, kasi parang kararating ko lang po kasi sir eh.
Okay. So no worries, sir.
Pasensya na sir.
It's all right. Okay, so we'll answer together exercise one and two. So let me just share my screen again. Um, okay, so for exercise number one, I guess I can put something on. Yeah. So, um, I actually forgot. RJ, did you make that into a function? I didn't actually check that part. I think it wasn't a function, right? They were
Hindi,
just.
sir.
Mm, so this is the part that you forgot. So my instruction was
Ah,
to
okay.
write a function. So,
Opo,
but
sorry
that's
po.
okay. You got the logic. All that's left is to put everything inside of a function. Okay, so let's say I have I'm defining a function, right? So I'll say def, and then I'll name it get even, right? I need an input here, so I'll name it numbers. This is my input list, and then call, right, for the function. Next is I'll create a blank for the even numbers, a blank list. So there you have it. Next is I'll create a loop. So for num in numbers, and then if, so the same with Sir RJ, if num modulo 2 is equal to 0, then it will only enter this condition if the number is even. So if num modulo 2 equals to 0, then what you will see is the even numbers, then we'll put it inside the list. So even numbers dot append and then num. So I'm using plain code here that we have used before. So I'm not using the what do you call that one? The list comprehension that RJ was using. So that was kind of a shortcut with the for loop and the if. What I'm doing here is I'm kind of expanding it so that you guys can follow as well. Because it's the same with what we have discussed before. After this, so after adding all the numbers to the list here, okay, all we have to do is what? It will return with a new list. So all we have to do is return the even numbers. And then all we have to do now is just call the function. So you say get even, and then you, I guess we can just print this one out directly. Print, and then get even. And then we pass in a list here of numbers. So 4, 6, 7, 8, 7, 2, 5. Yeah, I guess that'll do. Okay. So if I were to run this, it will just give me uh, all the even numbers. And it's wrong. Expected, yep, I forgot that one. Input. I'm missing. Okay, now I see that it's 4, 56, 8, 54, 32. So those are um no, the sort is not returning anything. What did I forgot with sort? Sort Python list methods, and then what am I using wrong with the sort? Why is it not coming out? Sort, source to list in ascending order by default. Sort A, print A. I am referring to the list here itself. So I guess it doesn't work if it's not sorted out. Um, Maybe something like this, and then return that one. So I'll sort it out first. None. Oh, none. Let's try saving it to a variable. Temp this equals to get even. Let's just transfer this whole thing here. And then what we'll do is temp.sort, just like what it showed us here. I could say within a variable. None, it's none. What am I missing? Dot sort print a variable. So I have to declare the sort first before printing out, I guess, because this has no return function. I think I think this is it. Ah, there we go. So now it's a bit clearer. So 4, 8, 32, 54, 56. Okay. So that's it. If you guys want a copy, you can just get a screenshot, save it somewhere, and then review it for another time. For exercise number 2, we'll basically just use what we have learned in dictionaries. Okay. So we're gonna say def, and then we'll name it filter the dictionary. And then it needs two inputs, right? It needs the dictionary and then the key. Mm, Input dictionary and then keys. Okay. And what else do we need? We need the filtered dictionary, and this is just a blank one for now. Next is we're gonna loop over the keys for key in keys. Okay, so we have access to all the keys now of our dictionary. What else do we need? We need to check if the key is inside the dictionary, then we'll automatically add it to the mm, filtered dictionary, and we'll create a new entry there using the key, and then get the value of the original one, which is input dictionary here, and then access it using the key that we have already. So that way we can get the original value. Then we can just, after the for loop, we can just return the whole thing, the whole filtered one. And that's it. That's basically it. So if we just copy these things here, okay, those are our inputs. And if we call out mm, like output here, and then we'll call filter dictionary, we pass in our two inputs, temp and input list, and then we're supposed to get the filtered one out. Then all we have to do is print it out to see the actual value. So the answer here should be the same as this one, if it's correct. And there's an error. Go down. What's the error? Input list. Type error. What's the type error for? Type error. For key in keys, for key, if key in dictionary. Oh no, wait. If key in input dictionary. There you go. Uh, hmm. So line 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Mm. So take note, the error was here, right? The type error is here, but the error, the actual part of our code that needs fixing was this one, okay? So just try to analyze the error and follow it and try to see where it stops, because it's not always the same line that has the error. Usually it's in a different line. So input list, well, put this as well. Okay, run, and there we go. So A1, C3, E5. So there we have it. Same output as what we have here. So nothing really fancy, right? We have a blank dictionary. We're accessing the key, creating a new entry, and then getting the old value, putting it in that key, but it's in a different dictionary now. It's a filtered dictionary. So I hope this makes sense. So what I've noticed is that you guys seem to lack practice. So have I shared to you guys the website called Code Wars? Have I shared that to you yet? Not yet. I'm guessing not yet. Okay, so there's a really fancy website here. Not yet. Not that fancy, but this was really useful for me before when I was beginning. If you want to get used to the language that you're using, you always have to use it, right? Again, programming is a skill. You have to use it always, otherwise you'll forget it. This is what Code Wars is for. Okay, so if you go to this website, I'm not advertising them in a way. I don't get any money from them. I just think it's really useful. If you go to this website, it's free and you can just register. So basically what you do here is commit 15, 30 minutes a day, or maybe 20, to answer one question, just one question every day. Um, so what you do is about 80% of your time, you try answer it by yourself without searching for answers on the internet. You can search for, what you try to do is don't lie to yourself. Search for you can search for functions that you can use and something like that, but do not search for the answers. Try to limit yourself and answer it by yourself. And then after five, with the remaining time that you have, um, whether you have answered it or not, just click on give up, right? And then it will take you to a page where it will show you the solution and the solution of how the others solve it. Okay, and then you learn maybe the top three or top four on how they solve it. What was their logic? What were they thinking when they tried to solve it? And that's really the best thing here because you can compare your solution with with how others solved it. Okay, so you actually learn a lot using that method. So you start at the lowest level where the things that they need are just very basic operations like mathematical operations, plus minus, those kinds of stuff, simple prints. But as you level up, per se, um, the questions get harder. Okay, and odds are the 15 minutes that you have won't be enough, or even the 30 minutes. There are some really difficult stuff here. Um, But that's not the point here. The point here is that you're training your brain to think like a programmer. That's the main point. It's not really about answering all the stuff here. So train your brain, look at the solutions that they have, analyze it, understand it, and try to apply it on your next problem. So that this has been really useful for me before. When I wanted to learn a certain language. And even today I use this one when there's a certain language that I will learn and I want to keep on using it um in the future. So I try to go at it every day if I can. So I try to do it every day I can if I can. So it has a certain section here like it has tests for your programs, like it passed one test, it failed five, and it will even explain to you why it failed. So that's really good. Um, So yeah, if you guys like this one, you can use it. So there are two different uh, coding parts. One is your actual code. The other one is the test case. So this is actually a bit more advanced. Um, so when you get to the point where you solved all the questions, the next part is to write test cases. So this one, the thing that tests other functions. You'll be the one writing that. So it's an entirely different way of thinking. But if you reach that stage, then it's a very big plus because a lot of companies are looking for skilled testers. Skilled testers are very, very few. Okay. If you imagine that there are a few programmers, there's even lesser testers. Okay. So they make test cases in order for your programs not to encounter errors that can make it stop. Um, yeah, those kinds of things. So yeah, if you like this kind of thing, go for it. What matters is that you're learning. Okay. So yeah, it's just a suggestion. If you guys find it hard to look for time to practice, So this is a good thing. 15 minutes a day, that should be enough. Um, yeah, since we all have difficult schedules, I know. Um, all right. So I guess we're done for this. Let me close this one for now and then open up the other one. Where is it? Uh, screen. Oh, yeah. So we're almost to the web scraping part. I hope you guys are excited for that one. Uh, and then here, here. Yeah, okay, I'm sharing this one. Um, okay. Uh, Presenter. And on to our final PowerPoint for the crash course in Python. So, um, as you can see from the title, it's called Design with Functions. Basically, it's more on the additional things that you might need in programming, but technically you're supposed to be done. Lists and dictionaries was the last part. At this point, it's just like the way of thinking, those kind of stuff. Not really anymore on how to use Python. So yeah. Okay. So pointer. All right. The odds are we can't finish this one in an hour, but I'm hoping we can finish at least half of it. Besides, it's all almost all just a way of thinking and some other extra stuff. So this is just a review. Um, Functions as abstraction mechanisms, because that's basically what functions are, right? If you remember the print function, we don't really know how it works underneath, right? We don't know the code underneath the function, but we do know how to use it, and that's the important part. I mean, at least in the beginning. So, developers really try to make good documentation so that a lot of users will use their library. Okay. Um, Take, for example, Python, right? It has a good documentation. It has examples. It has good parameter namings, and then it has also a lot of user base. So there's a lot of users already. So that means you have to be more specific with your documentation. Um, where am I going with this? So yeah, odds are we'll just be using functions made by others. If you want to take a look at functions or libraries that look bad, right? I'm not saying that all libraries are like that. It's just that other libraries are not maintained as well as the others. Let's say, for example, forgot the name. Let's just look for one that's good. So this is one that we will use later on. It's called Pygel. So we'll use this one to create charts later on. When we get to web scraping. So we have Pygol here. Um, if you go to documentation or the API, um, let's see, config colors. Now I guess we'll just go to documentation for now. I think it's easier to see here. All right, first steps. Okay, so from the structure, you can see that they put different sections. So if you're looking for chart types, you can skip to that directly. You can go to styles if you want to customize it. Configurations, series, values, and then sprint lines if you want as well. There's also different kinds of outputs you want, especially for different types, like if you want it in SVG and PNG, right? If you also want it to be embedded in a web page, there's also a section for that. But the main point here is that it's organized, right? It looks good. And in relation to our topic here, functions as abstractions, because if we go to the first steps, the good implementations usually have first steps. This just gets you going. It gets you to make the library work as fast as possible. So here's an example of how that library works in a browser. So it's a very interactive chart, you see. So if I hover my mouse there, it kind of highlights. If I click this one, it will disappear. If I click on that one, it will appear. So imagine if there are other charts here as well. So you can combine those things. It's very interactive. You can highlight your mouse here to see the actual values, right? You can even click one you want, but there seems to be no effect on this. Um, but yeah, so here, for example, there are two graphs. So if you unclick this one, right? See, so that's the effect it has. So it's a stack bar. This one is a horizontal stack bar. This one, more. So basically, this just gets you going. Now, if you're interested, right, you go directly to specific chart types. Say you want to learn about radar, for example. Okay, so this is what the radar looks like. Okay, and you start looking at the examples that it has. So usually it looks something like this, right? So Pygol, the radar. Um, it's using the different properties and methods that it has. So add and it has X labels. Cycle. So take a look at this format. Okay, it kind of looks like what? That add. So that add here is a method, of course. That render is a method. X labels is a property. Type is a property. So you're just assigning values to what? To the object itself, right? You have methods and properties. You're assigning values to those properties, okay? And for the methods, you're just using the methods to assign values to your own chart here in this case. So I wonder if I can edit here. Nope, I can't. And then the last part is the render. So this function will automatically render this one, okay, or show it to you on your screen. So as you can see, we didn't really create any new functions, right? We're just using the ones that it has already. And this is usually the case when you are using libraries. Um, you tend to just use what they have, okay? You're trying to adapt to what they have. Um, that's the main point, right? Because they've already made solutions for it. All you have to do is to learn how to use the different functions and the sequence of how to use it. So usually that's the case. And yeah, so more things to learn. So depending on what you're working on, the libraries that you'll be learning will also differ. So if you're in a data science, you'll be learning these libraries. And then there will be even more libraries to learn afterwards because there's always going to be something new, something better, something more efficient. for these kinds of projects, something like that. Or if you shift entirely, let's say go to web development, for example, so there are even more libraries there that you can choose from. So it's basically just an endless um, process of learning. In terms of the things that you need to learn, there's really a lot here in um, in this specific kind of work that we want to get into, which is IT, right? So yeah, I said a lot of things here, but the main point here is that it's abstraction. It's hiding the main thing, code, which makes it work. Okay. So if you're asking, sir, can we see the actual code? Yes, you can actually see the actual code. If we go back to that one, I shouldn't have closed that one. You want to see the actual code. There's usually something like this. Edit in GitHub. Go to GitHub, and this is where they store their code base. This is the repository, right? If you say index here, let's look for their actual code. Let's go to Pygo, and then docs demo. I think it's this one. Git, CSS. Nope, nope, nope. Bump. Do you start dropping? Yep, yep. Mm, sure. So as you can see, Pygo, right? These files were actually just updated 4 years ago, 5 years ago. So does it mean that it's inactive? Not really. It just means that their code, there's nothing to improve with their code yet. Okay, there's no security breaches in their code. That's what it means. Um, so let's see. Adapters, colors, config, A3. Here's one. It says stats, style. I'm gonna look for the actual part. Graph, map, tests. So these are the test cases. This will allow us to go back to the top. Good. Where's the actual setup? Where's the actual file? That's the starting point for the whole thing. Uh, sorry, that's just documentation. Let's see. Let's just open one, maybe stats here. All right, so as you can see here, okay, this is from their actual code, right? They are using this code to create uh Pygo for us to use Pygo, okay? So here you can see the actual code, right? And the users don't really need to see this one, right? I mean, we don't need to see this one, because odds are we don't even understand some of them because we don't know the whole context of the code base, right? In order for you to understand what this is referring to, you have to understand all the other parts of the code first, right? I mean, you can understand that this is logarithm, this is it's using an if, right? You can understand that one, but um, what does it pertain, right? Where does it go? Where does it lead to, if that's the point? So, um, yeah, it's all abstracted from us, basically. So here's some explanations. Approximation of the inverse error function, which is, oh, here's handy. There's a link. Okay, so this is a useful way to use comments. As you can see, they expected that someone will have difficulty understanding this part. So they added a link here that you can search later on in order to understand the logic that's happening here, right? And you can see that it's using default value here. Okay, it's importing a lot of things, log pi, this kinds of stuff. So yeah, if you really want to see the code, you can. And if you want to know why they allow this one, it's because of security purposes. So they have this way of thinking like they want a lot of people, right? Especially the ones that like Pygo to watch their code. Okay. So the theory is that if a lot of people are watching the code, there's less chance of malicious code going into the code base because a lot of people are watching. That's that's what they're going for. Okay. So yeah, that's the reason why they show their code base like this because they made it public. And that's basically it for that. Let's proceed to the next slide. Functions eliminate redundancy. Yes, of course. Instead of writing the code multiple times, you only write them once and then call the function. And then if you just want the output to be uh, different in a way, then you can just add a parameter to make it different, right? Instead of just making another function, maybe you can add a parameter for it. Okay. Highest complexity, same as subtraction, right? And then support general methods of with systematic variation. So uh, mm, I have nothing really to add here other than the bullet points. So general method of solving a class of problems. This pertains only to algorithm. Okay. Um, I don't know problem instances. So basically, the class of problems that we have, for example, are mm, like for example, mathematical problems. So the problem instance for mathematical problems are those like um, Fibonacci or factorial, those kind of. So that is a subclass of um, the mathematics class of problems. Algorithm should be general enough to provide a solution to many problem instances. While well, it may seem that generating algorithms is very easy. It's actually a bit tricky if you try to create one your own, because you have to remember that computers follow the code step by step, right? You have to guide it by hand what to do in the beginning before, okay? And it may seem that a lot of things right now seem like the computers are smart, right? Or something like that. But technically, it's just a lot of if conditions inside of it. Okay. And there's a really smart way of using neural networking and then some LLMs. So you'll get to learn those kind of terms later on um, when you keep on going with this job, right? So technically, data science is a precursor to AI, something like that. Data science and data analytics, because before AI can work, it needs data, and that data is provided by users and the developers or the ones that analyze the data and their outputs. So basically, we get the data, but the one that analyzes the data afterwards is someone else. That's also possible. Like if you're providing data for a scientist, right? I mean, your job was just to collect the data, interpolate the data, but your task was not to analyze the data. That's out of your field. So it's for someone else. So their task for you was just to analyze the data, get a graph of it, okay, use machine learning to have predictions with it based on past data, right? And make predictions. So that's basically what data science and data analytics are. Um, so yeah, functions support the division of labor. Yes, especially for computers that can uh, process different things at the same time. So you can, I don't know if you guys know this, but a single processor can be divided into smaller processors virtually to create smaller computers. So that's how servers are made. Um, so let's say you have one very big um, computer that's very high end, very expensive. And then what they do is that in order for it to become accessible to the regular person, okay, like us, to make it cheap, for example, is that they divide it into a lot of smaller servers virtually, and then it becomes cheaper because now it's smaller in size. So let's say you have a one core server, one core, and then it only has 2 gigs of RAM and then 256 gigabytes of hard disk, and then you sell that one for maybe $5 a month or $10 a month. So that's how they earn from that one, and that's how servers work. So uh, when you think about it, you're dividing the processor into smaller parts. So essentially, it's um, it's processing a lot of things at the same time, right? It's not it's not how do you say this? It's not doing one and then going to the other after that. So it's just doing it in parallel. Okay, so next is problem solving with the top-down design. So I think you guys have used this one already in your high school days, college days. So basically what we're doing is that we start with the main problem and then decompose it into smaller problems and decompose that one further into smaller problems. So we call it one problem decomposition, right? And then after decomposing it to the smallest possible problem, you start solving it from the bottom up, right? That's what we do. And then eventually you will reach the answer at the top. But yeah, it can get kind of daunting, right? To start, start at the main problem when you're looking at the main problem as a whole, but it becomes easier when you start decomposing it. And when you decompose it, you can assign it to different people. Okay. And then all you have to do at the end is just combine all your solutions. And that for me is very efficient. And that is also how companies work. Like let's say for example, Facebook, right? They have this main code base, all right? One team is working for one feature, another team is working for another feature, right? And anytime at any point they can put their feature in the main code base and then into the live website, right? It works directly. So it's not really a problem with composition, but it's more like different tasks are assigned to different teams. So there's no really stagnation at that point. There's always someone developing for Facebook. So I hope you get the idea. Um, yeah. So here we have this design of a text analysis program. Basically, we'll try to analyze the way that um the way that we think, okay, when we are trying to solve this problem. So basically a text analysis program. So from the name itself, we're analyzing the text itself. So what does a text contain? It has paragraphs, it has words. So I'm not really an expert on language, um, like English language, you know, the, the things like how to analyze it. But, in the context of this program, let's say that we actually do know what we need to analyze, right? In order for us to kind of put a number on the text that we are looking at. So in here we have different squares. Okay, so it kind of looks like a flow chart, right? And this is what you usually see as well from your team leaders or your supervisors, right? Just to get everyone in the same page on what to do. So each box here is a different functions. So we have count synthesis, count words, count syllables, syllables LN. You have the flesh index, which I don't know what it is. And then the grade level, which I also don't know what it is. But I do know that these arrows are the data types, right? And I do know that this is the main problem. And these are the subproblems and the other subproblem, okay? So you can see it branching out, right? That's the main point of the problem decomposition, okay? And the arrows here are the data types. So you can see a string here, string is coming into the count, right? And then output here is the int, okay? For the count syllables, it's also string and int, whatever this one is. It will go back to count syllables and then uses this value here, the int, for the output here as well. So whatever the output here, it has an impact to the output of this function. Now, all these three integers right now go down the line and go here. You see, three ints. It goes to the flesh index and returns an output, a float. And then also the three ints go here, the grade level, and returns a float. So basically, the final output of this text analysis program is depends on these two functions, the flash index and the grade level. So based on these two, we can um, basically make an analysis, right, of our text on what its grade level is and whatever this index is, right? That's the main point that we're trying to get into. So yeah, problem, subproblems, and then from the bottom up, we try to solve the main problem again. Okay, so that's the main point that we're trying to do here. It doesn't have to be always squares. Like if there are parts where a decision needs to be made, it's usually a diamond. So that's a decision making um, figure. If there is a trapezoid, it's called a trapezoid. Forgot. The I forgot what it's called. The slanted rectangle, the slanted rectangle. Forgot the name. But this one also exists, the trapezoid. I think this was used for when you see this one, it means that you're storing data to a certain variable or something. Um, so again, these kinds of shapes differ from company to company or team to team. Usually they have their own things. Just so that everyone is on the same page, okay? Because you're not going to be discussing actual code with other developers. What you're going to be discussing is like the flow of the program, or where's it going to, where's it coming from, hey, those kind of stuff. So it's not rare, but it's usually the last part where anyone tries to discuss code because they assume that you already know what to do, something like that. So yeah, um, because it's a main loop, our generator system arounds. Uh, so this is important. The structure of the problem can often give you a pattern for designing the structure of the problem. It's kind of like it's going back in itself, but it's practically the same with what I said earlier. Oh no, wait, this is a different one. Oh, okay, this is for the sentence generator. Okay, that's where I was confused. So this is for the sentence generator program. And if you take a look here, right, if you analyze how the English language works, we have what? The main problem here is that we need to generate a sentence. Now, uh, the next question is, what is a sentence made out of? So it's made out of words. What kind of words exactly? Not words, but we start with phrases. So we have a verb phrase and then the noun phrase. So there's just these two. And you can decompose the verb phrase into prepositional phrase or just a regular verb. Um, prepositional phrase can be decomposed into either a noun phrase or a preposition. Okay, and the noun phrase can be decomposed further into articles or nouns, right? There are certain instances where the noun phrase can be directly a sentence, right? Or even the verb phrase can be directly a sentence. Um, Maybe it doesn't really indicate, right, that this alone can work or this alone can work. But I don't think it does because of the word phrase, right? And a can a phrase be a sentence? Just a basic research. No, a phrase is not a sentence. So no, this is not wrong. So just one of them is not enough. It needs both of them in order for this to become a sentence, right? And at the bottom here, you can see the basic stuff that we learn in English, right? The verbs, nouns, prepositions, articles. And then finally at the bottom is the data pool, which I assume is all the words in English, right? So yeah. Noun phrase. So if I remember noun phrase, um, no, I don't remember noun phrase. I remember articles. It's and the prepositions are the in, the on, the at, under, over, those kinds of stuff. Um, so if you say prepositional phrase, it's on time, right? Yeah, I think that's a phrase. Um, Verb phrase is, of course, something with a verb. Um, yeah, that's how deep my English language knowledge is. So, as you can see, all the data types are just strings. See, so depending what the problem, you're gonna have to get accustomed to the actual context of the problem. So if your problem is about the sentence, then you're gonna have to learn how sentences work, how it's structured, what the rules are for creating a sentence, right? You're gonna have to take it into account when you're trying to solve the problem. So yeah, um, I don't know with you guys, but yeah, that's the limit of my English knowledge. Although I can speak it, but you know, moving on. So the third program that we have here is the design of the doctor program. I think we'll stop here after this. Okay, it's almost 5. So the doctor program. So the point of this program is that um, it will act like how a doctor should respond. That's the main point of this program. Um, so it starts with the main here, passes a string to the reply. I'm guessing this is the question from the patient. Okay. And then it passes it to the change person. It passes it to the change person. Hmm. Hmm. I don't know, wait. So from the reply here, string, okay? So it collects 3 things. The strings, the headers, the qualifiers. Yeah, the headers and the qualifiers. So from the name itself, headers, these refer to words or phrases that soften the impact, okay? Like maybe the word I guess, or it's sort of, okay? Perhaps those words, okay? The qualifiers are like additional information. So if you say the words possibly or partially or somewhat, okay, it kind of adds more information to what you're saying. And those words are what you commonly hear from doctors, if I'm correct, right? Um, so those are hedgers and qualifiers. Okay. Usually hedgers are the most common thing that you can hear because it softens the impact. Um, like I don't know if I should joke about that, but it just softens the impact uh a little bit. I don't know if that actually helps. But after that, passing the strings here, uh, it collects all the strings and then passes it to the change person. The change person will also collect the replacements. The replacements are, we can see in the next few slides actually. They just change the view of the sentence. So from my first person view to a second person view. Okay. So basically the pronouns. So the first person pronouns are swapped with second person pronouns. So that's what the change person is. We can see that there's a few lines of code we can see on the next couple of slides that we can see what the replacements are and the change person. But for the other parts, we don't really see the code for that. Okay, so after collecting those strings, it will return the new reply that it means, and then it returns that back to the user or the patient. And where do you see this one being applied? So if you've been to websites that um, have kind of like a record or a database for a user, and then they have a chat box on the right. So usually that chat box is um, nowadays is kind of AI. So they might be using something similar to this, all right? That um, you know, softens the impact and then changes the person from I to you, those kinds of stuff. So from a top-down approach, it doesn't really look like a top-down approach at first, when you first look at it, right? Because it's kind of a square, basically. So you don't have to stick too much to the definition of a top-down approach. As long as you are creating sub-problems from the main problem, then that's good. That's good enough. So as long as you're dividing it to smaller pieces of problem, that's always good. And that's it for the doctor program. And that's good because the recursive functions are a bit confusing. Um, so this is where most of my students get confused. Recursive functions. So I guess this is also good that we ended up here. I guess I'll just note it here somewhere, maybe at the top. Okay. So for B of above. Yeah. Uh, recursive functions. Just so that I'll remember where to start next. Right. So that's it for today, guys. Do you have any questions, clarifications?
Sir, ask
Yes?
ko lang,
Yes, po.
gaano po kabilis ma-upload yung recording po?
I'll try to upload it after this class because usually Zoom takes about an hour or sometimes 2 hours to convert. This is a 4 hour class, right? It takes a long time sometimes. If not today, then tomorrow. I'll make sure to upload it early this time.
Copy, sir. Sa portal po ba yun, sir? Or
Still
parang
in YouTube.
yun,
It's still in YouTube.
YouTube din po?
Yeah,
Okay. Okay po. Thank you po.
no worries. How about the others? Seji, RJ?
I do have one question, sir. So I was able to log into the Code Wars website that you recommended.
Mm-hmm.
I'm trying to find like, is the only real way to train these skills be the practice stuff and suggested challenges? Is that the only thing I could use for it? Like for building up on basics, fundamentals, all that stuff. Or any other is there any other what's the term for it? Anything else from the website that I can use for it?
Mm, other than getting used to, it sort of trains your mind really to think like a programmer. But other than that, um, nothing really. They have a page where they have a collection of things that you have solved. So maybe you can use that one for portfolio purposes, but you know, it depends on you.
Portfolio purposes. Ah, okay, sir.
Yeah.
Thank you.
If you want to put that one in your resumes or those kinds of stuff, at least they know that you're actively learning those kinds of things.
Ah,
Yeah.
interesting. Okay.
Yeah, you can try and research that one. They should have a page somewhere like that.
All right. Thank you, sir.
Yeah. How about you, RJ? Are you good? Uh, yeah, all good. Okay, so that's it for this week. Enjoy your weekend, and I'll see you next time. Goodbye.
Fine, thank you, sir.